Got it. Question.
Prince exam, I'd be excited too. I'd be open to these.
Like another problem, like you can find one online, but what if we got like 3 multiple choice? Or 2?
Just correct it and tell me why you got it wrong. Yeah. Yeah, that's a good point. I was thinking of only the work through. Okay, so exam grades were for the most part awful. Still managed to get 100. 6 people got A's. Very high A's. 8 people got B's. 16 C's. 23 D's. 38 F's. This is not good. And can you maybe give me some feedback? Like, what happened? Samuel?
Did we ever do an example that involved using gear ratios? Because that's what we needed for the last problem.
No,
is
it's
what it
not.
seemed like.
It's
No,
all
that's
no
what I
slip.
did.
It's no slip.
That's what I did, but it's not what you needed to do.
Annabelle?
Well, it's just the same thing where I don't think we had enough like homework examples where we had to do the no slip thing, or I just don't remember like having like when I did practice, which I did for the exam, no slip, just like switch one of those things that we mentioned in class, but was never on the homework.
Okay.
Or really the recommendation exam.
I'm not saying
Yeah?
it was wrong. Please.
You don't like multiple choice. I'm sorry. There's no getting around it. Look, when you look at the grades on the number of points available and the points received, people got the most, like, percentage correct on the concept questions. Do you want me to take away those easy points? No. Okay, then I'm not taking it away.
That guy's crazy. That guy's crazy. I don't associate.
All right, what's next? What else happened?
Oh, I have a question.
Yeah?
Which way did you want us to use this problem? Because I did it both ways to make sure I covered all my bases.
I don't care.
Okay.
If you got the right answer, I don't care.
Okay.
There were multiple ways.
Because it was like
Physics is physics. If it works, it works.
Yeah.
I was like, but we
Okay,
work in energy.
so grades were bad. I'm going to give a redemption. I don't like it because I've given so many resources. I can't think of a different way to give more resources. Like, I don't want to assign a boatload of extra homework because there are people who have to work extra outside. Like, they have to work either full or part-time to keep afloat in undergrad. And I recognize that. And so the homework that I assign is the bare minimum that will give you exposure to the type of problems I expect you to know how to do. If you need extra problems, we've talked before about where to find them in the book. I gave a practice exam. Was there another question?
This was about the final. Is it cumulative?
Yes, the final is going to be cumulative. I stand by what I said after the first exam, which is I will not give you a course grade lower than your final exam grade. Okay, so if you are making a 20 in the class, but you make a 90 on the final exam, you get a 90 in the class. Now, if it's reversed, if you're making a 90 in the class and you get a 20 on the final, I'll do the cumulative. I'm not going to give you a 20 for the class just because you bombed the final, okay? I'll give you whatever it averages out to according to my syllabus. But if you pass the final with flying colors, my understanding is that you finally learned the material and you're ready to move on to the next class, okay? Questions about that? Yeah?
Is the final going to be weighted more towards like the new stuff that wasn't on exam 1 and 2, or kind of even?
Yeah, so what I've told everybody is that it's cumulative. I'm going to test your knowledge of everything that we have learned so far, but recognize that because of how much this class builds on itself, especially like the problem with the safe and the pulleys, you had to do dynamics there, but you couldn't forget the pulley material, right? Because it builds on itself so much, I'm very easily able to test your knowledge of the previous material by asking you a question whose main focus is more recent material. Does that make sense? Yeah. Question, Robert? It'll be more questions. Yeah, I believe last year I did 5, but we'll see what I can find. Because it's a 2-hour exam, so it's longer. Okay? Any other questions? Yeah, Leah?
Is there going to be a solution guide posted?
There is a solution guide posted, but there is one issue I already found. I put the wrong words to go with selection B on concept question 5. The correct answer truly is B, but I said always negative. It really should be always 0. So there is one error on the solution guide. Correct answer is in fact B. Yep.
If you're at an 89 in the class, do you have no points?
I do my very best to try to make, well, if you look back at the syllabus, there's also other things that I do, right? I'm dropping the 2 lowest homework scores. I'm dropping, I think, your 4 lowest bell ringer scores. Okay, these last little dropping of lowest things are meant to get you from a borderline grade up to the next grade. So hopefully it does just that for you. But I do try very, very hard to not leave someone at like a 9 something, right? I usually bump it up, but I'm not saying always. That's up to my discretion. Whether you've been in class, whether you've been taking the bell ringers, that's all I'm going to say. Okay? Okay, so here's your redemption assignment. It's already posted. It's in the Exam 2 module. It's listed as Exam 2 redemption assignment. So for each problem that you got wrong, that you would like to earn points back, you may earn back half of your missing points. So if you got half the so there were 30 points per question. If you got 15, then you missed 15 points. That was a bad example. You can get, what is that? 7.5 points back. You can earn 7.5 points back for that problem if you do the following assignment. So for each problem where you want points back, I want you to go back and look at the solution guide that's now posted. Make sure you understand how it was done. Make sure you understand what it was asking you for. And then go to the textbook. If you don't have a textbook, find a friend who has a textbook. Go to the one of the fundamental problems section. I need my book. I've shown this before. For each chapter, they have these burgundy question sections that say problems, but there's these orange sections that are special that say fundamental problems. Those are special because they have a kind of pitiful but solution guide in the back of the book specifically only for those problems, okay? So that's why I want you to choose that type of problem so that you can check your work. But what I'm asking you to do is to create not just an answer for the problem, but a solution guide. You've now seen how I do solution guides for 2 exams, every single homework, okay? I want you to look back and notice how many steps I show. Notice how many notes I put about what you should be thinking about or what equation you should be considering using. You are to create a solution guide for the problem that you find from the fundamentals problem section that's similar to the exam problem that you're making up for. Questions? Yes?
So we can't make up points on like a misconceptual question, just the work.
Okay, yeah, sorry, yes. So conceptual questions, if you want to make points back on conceptual questions, I'll give you the 1 point, half a point?
It's 2.
Yeah, but I'm giving half credit back. So I'll give you half a point back if you explain what the correct answer is and why. Okay? Turn it in the same PDF that you're doing all the rest. Yeah, Caesar?
Yeah, so half credit's 1 point back.
They're worth 2 points apiece, right? Oh, okay, it's 1 point back. You're right, sorry. Brain is not braining. Yep.
So for the third one, the full no slip, is it fine if we just do a single no slip, or does it have to be another program, the fundamental that has 2 things that are no slip as well?
No slip is not the point of the problem. The point of the problem is rigid body dynamics.
So it can be anything from chapter 7,
Yeah.
not just, okay.
I would prefer it match as closely as possible, right? So like, fine, find something similar. I don't care. Other questions?
That's what I'm saying. I need an 88 on the file if I do.
But you have to check that the answer is correct, okay? You're writing a full solution guide and giving me the correct answer. If you give me some baloney that doesn't make any sense, I'm not counting that as giving you points back.
Is that information?
Yes, this is all in the assignment document itself. Yep. So I'm wanting you to upload a PDF to the Exam 2 redemption assignment due April 23rd at 2 p.m. So that's not this Thursday, but the Thursday after. Okay? Final questions, final concerns. Yep.
Can we ask you if we got, like, can we go to, like, office hours and see if we got it right?
Have I ever told you no that you may not go to office hours?
Well, I know, but it's like an example.
Yes. you may come to office hours. Use your resources. I mean, the solution's in the back of the book, right? But if it's too sparse, come to office hours. I'm happy to help. Yep. The point is that you learn it before the final. All right, I'm moving on. Okay. We have talked about impulse and momentum for particles. We talked about linear momentum, and we talked about angular momentum, all for particles. What do you think is the next step? Rigid bodies. We're going to do linear momentum and angular momentum for rigid bodies today. Okay? Alrighty. So just to be a little extra clear, we're going to do both linear and angular. All right, so let's remind ourselves, for a particle, what was the expression for the linear momentum of a particle? Any ideas? Can you flip back in your notes? Mass times velocity. Thanks, Micah. Mass times velocity. Notice that I'm keeping this as a vector because momentum is a vector quantity. All right. The way this changes for a rigid body should be very about point O equals R cross MV, where R is the vector from O to the particle. Okay. For the rigid body, if we happen to take the angular momentum of the rigid body about its own center of mass point, we call that Hg, and it's equal to Ig. I is always the mass moment of inertia of the body, omega. And in this class, we're only going to talk about planar kinetics, so this will always be in the k-hat direction. So out of the plane. But we can calculate the moment of the angular momentum about words are hard. We can calculate the angular momentum about any point. Okay, so I don't necessarily have to take the angular momentum about point G. I could take the angular momentum about some point A. If it's not the center of mass point, then I need to use this modified equation. We still have the Ig omega, but now we have D dot MV G K hat, where D is the distance between G and A. Okay. Principle of linear impulse and momentum for a rigid body. Is not much different than for a particle. I just substituted in this new fancy version of linear momentum. Okay, linear momentum at time 1 plus the sum of all impulses acting on the body or on the system equals the linear momentum at time 2. Angular momentum is not too different either. If we're taking angular momentum about the center of mass of the body, we have angular momentum at 1 plus the sum of all impulsive torques about G equals angular momentum at 2. So notice the consistency of the G's throughout this equation. Alternatively, we could have said this is really HG1 and HG2. So similarly, if I am looking for the angular momentum about some point other than G, I have HA1 plus some torque impulses MA dt equals HA2. Okay, I'd like to set the stage a little bit for how I want you to think about problems that use these momentum equations. So when we did equations of motion, we did sum of forces in the x, sum of forces in the y, and sum of moments about g, right? So we had basically a linear equation in the x, a linear equation in the y, and an angular equation in the z, right? There's going to be this beautiful parallel here using impulse and momentum. So when we're considering for a planar system with rigid bodies, I want you to think about when it comes to do the equations of motion part of your problem. You know how we set up every problem. We do known, find, free body diagram, and then equations of motion. I want you to think about if you've decided to use momentum equations, can I use linear momentum in the x? Can I use linear momentum in the y? Can I use angular momentum in the z direction? Okay, so there's a kind of your 3 options for equations that might be useful in this domain. Same way, we had those same 3 options when we did equations of motion. Okay, x, y, some angular thing about z. X, y, some angular thing about z. Okay, so I'll walk you through this. But I hope that helps a little bit. All right, let's do a problem. Okay, we have a disc and we have a bullet hitting this disc. Determine the height h, at which a bullet can strike the disc that has a weight of 15 pounds and cause it to roll without slipping at A. So note, they're telling you that it's okay for you to assume in this case that the frictional force at A is essentially 0. That's not always the case with roll without slip. Not always the case with roll without slip, but this particular problem says it's okay. Okay, so let's think through this exactly like I just said. Let's maybe go ahead and do our known. The known, we have a weight of the disc is 15 pounds. So if we need the mass, it's 15 over 32.2. We're going to be doing roll without slip. Okay, what type of relationships do we get when we know roll without slip is happening? We should get that the velocity of the center of mass is equal to omega r, or that the acceleration is equal to alpha r. Not entirely sure which one of those will be useful right now. Okay? And then it says no friction at A. What is it asking us to find? Wants us to find H. Let's do a free body diagram. I'm going to draw a free body diagram of the disk. There should be a normal force. Bless you. This thing has weight. That'll be 15 pounds weight. This thing is 0.25 feet. And there's some impulsive force F that's going to strike this disk at a height, bless you, of H. What? Okay, so which of these is going to be helpful? One, principle of linear impulse and momentum in the x direction. 2, principle of linear impulse momentum in the y direction. Sorry, I needed to find an x and a y. X, y. Or 3, principle of angular impulse momentum in the z. Which do we think is going to be helpful? Do we expect there to be some change of velocity in the x direction? Yep. I think that this is very likely going to be useful. Do we expect there to be some change in angular velocity about the z-axis? Yep. I think this one's probably going to be quite useful too. There's really not going to be a change in velocity in the y direction for either of these objects. So I don't really know if 2 is going to be useful to us or not. Okay? So for the time being, let's first look at writing out our principle of linear impulse and momentum in the x direction. Okay, so if we do 1, that equation looks like this. We have m vg x 1 plus the sum of impulses dt equals mvgx 2. What do we know about linear momentum at time 1? Why is it 0, Annabelle?
Disk isn't moving.
Right. Yep, we can assume that we're not moving, so we're starting from rest. If we were to look at writing out our impulsive forces, what are the impulsive forces happening in the x direction? based on our free body diagram? Yep, just the bullet force, okay? So we have integral from T1 to T2 of F bullet dt. Do I know what F bullet is? Nope. It's going to change with time too, right? It's going to start out very small, get really, really big, and then get small again. So I'm going to actually treat this entire term as a single unknown. One unknown. Okay, what about the right-hand side? Do we know the final velocity? Nope, we sure do not. Okay? We do know the mass, or at least we can find it. So we have two unknowns here, one equation. Okay, so I really hope that equation 3 helps. So let's write our principle of angular impulse and momentum in the z direction. Angular impulse, just for the sake of simplicity, let's try to find the angular momentum about point G, or the center of mass of the body. So we'll say I, G, omega 1, plus the sum of our torque impulses Okay, tell me about angular momentum at time 1. Yep. The disk is just sitting there, so it has no translational velocity and no rotational velocity. What might be causing an impulsive moment about G? Can the 15 pounds be doing that? Nope, it points right at G. What about the normal? Nope. What about F bullet? Yeah, F bullet causes an impulsive moment. Okay, so we'll have the integral from T1 to T2 of F bullet. What's its moment arm? Well, it looks like it would be h minus the radius of the disk, right? Because this is 0.25, and this is the moment arm here. Okay, so I'm going to say h minus 0.25 dt equals ig omega 2. Yes, Leah?
Do we have to worry about whether it's a positive or negative moment?
Oh, that's a great point.
Because if you're something about G, it would be negative.
It would be negative. Yes, we do need to worry about that. Thank you. Yes, Seth.
If there was friction at point A, would that be like an impulsive force too?
Yes, potentially. Yeah. We would need to consider it. Okay, what other unknowns do I have? Well, there's actually one of our unknowns is hidden in this equation. We just need to rearrange a little bit to see it. So h minus 0.25 is not going to change in time at all, right? So that can actually get pulled out of our integration. So we should get minus h minus 0.25 times the integral from T1 to T2 of F bullet dt, which is the same unknown we had in the previous equation, right? It's just showing up right here. So that's nice. It's not a new unknown. Equals ig omega 2. Well, I don't know omega 2. So it looks to me like we have two equations and three unknowns. 4 unknowns with h. You're right. So our unknowns here are the integral from T1 to T2 of F bullet dt. We have VGX2, we have omega 2, and we have H. What's a relationship that we can use, though, that we haven't pulled yet? Say again? Yes, absolutely. So this thing is rolling without slip, which means that this linear velocity is related to this angular velocity by the no-slip equation. So VGX2 is equal to omega 2 times the radius of the disk, which is 0.25. All right, I'm going to box all the equations I'm going to need. Okay, now I have 3 equations. I still have 4 unknowns, which should make you a little bit uncomfortable. But bear with me. Something magical happens in this problem where one of our unknowns cancels. Okay? We are actually able to solve this problem the way it is now. Okay? So, let us... What is it wanting us to find? We need to find H, right? Okay. So let's maybe... Do we want to get rid of VGX or do we want to get rid of omega? Let's do this. Let's work on equation 1, and we'll say that the integral from T1 to T2 of F bullet... Oh, you know what? I'm changing my mind. Sorry. That one's already solved for one of our unknowns, so we might as well go ahead and plug it in equation 2. So equation 2 might look something like this. H minus 0.25 times, instead of that integration of F bullet, we'll have M VGX2 equals IG omega 2. And then if I plug in for VGX2, what I'll end up with is an omega 2 on the left and an omega 2 on the right, and they will cancel, and we can solve for H. So let's do that. So minus H minus 0.25 times M times omega 2 times 0.25 equals IG omega 2. Okay. So we have an omega 2 here and an omega 2 here. Those cancel. We should be able to solve for H. And then this is just a flat disk. So IG for a flat disk is 1/2 mr squared. So we should 1/2 m 0.25 squared. Looks like the masses cancel too. We should get something like H equals to 0.375 feet. Yep.
Is that relationship with angular velocity, is that only valid for no slip?
This is roll without slip. Yep. If it's slipping, doesn't hold. I'm wondering if that sign error felt. I think the sign error that you called out earlier might have actually modified the answer. Let me double check. I might have to check after class to find it, but. $19.6.
I mean, wouldn't there be two answers? Aren't there two reasonable answers? One above the center of mass and one below.
Without friction, that might be true. But if there really were two answers, I would have expected to have two different solutions. Oh, okay. No, I didn't carry through my sign error, Annabelle. So this omega here, if we think about the bullet hitting at the top, it's going to cause a rotation in that direction, which is also going to be the negative k direction. So there's a negative on both sides, or just not a negative to start with. So in all actuality, this is probably the most correct, would be to put a negative on both sides. I think that goes here and here and here. I think that does it. Good work, team. Okay. Questions? Yes.
Can you explain that sign error one more time?
Yes. Yeah. So when we're talking about equation 3, it's still a vector equation in that we're talking about either positive rotations about the z-axis or negative rotations about the z-axis, right? So the moment that F causes about G is, my thumb points into the board, that's negative z direction, right? However, the kinematics that result are going to cause this thing to rotate this way, which is also a rotation about the negative z direction. So we end up with a negative moment on the left, but also a negative angular velocity on the right. So the negatives cancel. Good deal. Okay, so I dearly, dearly hope that everyone is seeing this common thread that I've been doing for almost every problem that we do lately. Writing down the known, writing down the find, drawing the free body diagram, and then thinking about equations. Which equations do I think fit this problem? Is it possible that we could have done this entire problem with our normal equations of motion? The only reason that I think no is because this impact with the bullet is causing an impulsive force. And our impulse momentum handles the fact that this force is changing through time. Braden?
For the relation between angular velocity, would you also have to make that angular?
This one? This is the same thing. So velocity will be going to the... Hold on. This is... I think this is a scalar equation. Like the magnitude of the velocity is equal to 0.25 times the magnitude of omega r.
I'm pretty sure it is.
But I mean, you can see visually too, based on our coordinate system, that a linear velocity to the right must be associated with an angular velocity about the negative z. So really, it should be taken care of here. Okay, so this problem deals with an impulsive force. Impulsive forces come up beautifully in the equations for linear momentum. That's why I thought impulse momentum equations might be useful. And then we need to think about, okay, is the x direction useful? Is the y direction useful? Is the angular momentum about z useful? Just like we do with our sum of forces in the x, sum of forces in the y, sum of moments about z. Sometimes you need all three of them. Sometimes, like in this case, you only need two. Okay? All right, let's do another one. The spool has a weight of 30 pounds and a radius of gyration of K0 or KO equals 0.45 feet. Let's remind ourselves of what that means. KO equals the square root of IO over M. So it's really just a fancy way of giving you the mass moment of inertia. A cord is wrapped around its inner hub, and the end is subjected to a horizontal force of P equals 5 pounds. Determine the spool's angular velocity in 4 seconds, starting from rest. Assume the spool rolls without slipping. All right, so now I'm seeing a change in angular velocity over a change in time. That's big light bulbs for impulse momentum. And in fact, it's big light bulbs for potentially using angular impulse momentum, right? Because I'm talking about an angular velocity over time. Turns out there are two different approaches that we can do for this problem. One is that we can do the angular momentum about O, and then the linear momentum in the x direction. Or we can do angular momentum about point A, and that's the only equation we'll need. But we'll do both approaches just so that you see the different options. Okay? This one there is friction. Yep. Okay, so let's do known. What do we know? Spool has a weight of 30 pounds. So mass equals 30 over 32.2. A radius of gyration, K naught, equals 0.45 feet. If I were you, I would potentially consider going ahead and solving for IO. And then let's see. What else do we know? Cord is wrapped around its inner hub and the end is subjected to a horizontal force of P equals 5 pounds. It's asking us to find omega when T equals 4 seconds. Starting from rest, so omega 2 when T equals 4 seconds. Omega 1 equals 0 because we're starting from rest. And the spool rolls without slipping. Let's do a free body diagram. Okay, I'm going to do my tension force P is 5 pounds. I've got a weight at O of 30 pounds. Got a normal force and a friction force. This outer radius is 0.9 feet. Inner radius is 0.3 feet. All right, known, fine, free body diagram. We're being asked about a change in velocity over a change in time, which makes me think what impulse momentum equations might be useful. So of course our options are 1, linear impulse momentum in x, linear impulse momentum in y, angular impulse momentum about the z-axis.
For the moment of inertia, do we have to assume that the spool is a disc?
Nope. That's the beauty of giving you the radius of gyration. Radius of gyration always, always, always equals the square root of I over m. So you don't have to assume a simplified shape.
Oh, we can just solve for I.
Yep.
Can that be used in like other equations where it's not explicitly stated?
Say that again.
In other equations, is that equation able to be used if we're given it, but it's not explicitly stated?
This one?
Yes.
This is always the relationship for radius of gyration and how it's related to mass moment of inertia. So if you're given radius of gyration, you will need this equation to find mass moment of inertia. Okay, approach 1. We're certainly going to have a change in velocity in the x and a change in angular velocity of this disk. So my first thought is to use those two equations. So linear impulse in the x, angular impulse about z. All right. So let's do 1. We'll have mvgx1 plus the sum of impulsive forces T1, T2, Fx dt equals mvgx2. We are starting from rest, so momentum is 0 to start with. I have two forces pointing in the x direction, so I should have the integral from T1 to T2 of 5 pounds. Sorry, I need to give us an x and a y. I always forget that. 5 pounds minus the force of friction dt equals mvgx2. Now, does it even tell us any way to figure out what that force of friction is in any more detail? We're not told the coefficient of friction. So really, I have no hope but to leave this force of friction as an unknown. Okay, so let's do that for right now. We'll leave it as an unknown. So we have two unknowns, and then let's do the other equation we decided on. So angular impulse momentum about z. I'm going to do angular momentum about point O. So let's do HO1 plus sum integral T1 to T2 MO dt equals HO2. We have no angular momentum to start with. Again, there's no initial velocities whatsoever. The moments being caused, we should have integral from T1 to T2 of let's see, what's going to cause a positive moment? The 5 is that right? 5 times 0.3 minus force of friction times 0.9 dt equals I/O omega 2. And we can actually plug in our time bounds on these equations too. We're going from time 0 to time 4 seconds. Okay, what other relationship have I not pulled on yet?
Roll without slip equations.
Did I do something wrong?
Do we not have to add because we're doing a different point other than this mass, right?
It is the center of mass. O is the center of mass.
Oh.
Yep. Good thing to check though. Roll without slip? Is that what you said, Samuel? Yep, we haven't done roll without slip yet. So VG x2 equals omega 2 times R. Okay, so here we have 3 equations and 3 unknowns. What are all of our unknowns? Force of friction, omega 2. That's it, really. So our unknowns here are the force of friction, omega 2, and VGX2. Okay, but we have 3 equations, so we can solve this system of equations. And what we should get is omega 2 equals 12.7 radians per second. Force of friction equals 2.33 pounds. I'm going to move just a little bit quickly to make sure that I get approach 2 done, okay? So that's one approach. A different approach which personally I think is a bit easier, is to try angular momentum about point A. Where's point A? Point A is the one in contact with the ground. Yeah, Samuel sees one simplification already. So there's only one force causing a moment about that point. That's a simplification. Let's play with it. So HA1 plus the sum of integral T1 to T2 MA dt equals HA2. Well, angular momentum is still 0. The only thing causing a moment is that 5 pound times 0.3. Now we do need a little bit more complicated expression for HA2, right, Connor? Yeah? So A is not the center of mass point. So now we have to say this is IG omega 2 plus dmVg. We still get our roll without slip though. So this is omega 2R.
Why is the moment still times the 0.3 when we're doing it at a different point?
It should not be. It should be 0.6, shouldn't it? Thank you very much. Yep, I got the wrong moment arm. Okay, I can again fill in my time bounds because it's asking us specifically about 4 seconds, which means I can evaluate this entire integral quite easily. IG, this is, let's see, K naught squared times M equals IO. So it should be 0.45 squared times the mass times 30 pounds over 32.2. Times omega 2 plus the distance between A and G is 0.9 times the mass again times VG, which is omega 2 times R, which is 0.9. We should still end up with omega 2 around 12.7 radians per second. I'm still a little worried about these negatives though, because I didn't have this negative in my notes. And so that makes me wonder if I needed to assume the direction of motion. Let me work this one offline and check that negative and make sure we still get the right answer. But I'll check it after class and then I'll bring it back next class and we'll double check.
Is
Samuel?
IG the same as I naught in this equation?
Is, sorry, what, IG?
Is IG the same as I naught?
Yep, yeah, because 0.0 is the center of mass of the body. Right, so O is G. Yes, ma'am.
Would you do the same that you did for the last group, make the omega negative because the roll is like the direction that it's moving, or does that not apply?
I think you're right. I think we can assume the direction of motion here because pulling to the right, if it's not slipping, which direction should it be rolling, left or right? It should be going left. That's a positive omega. So the question then is, should I have made this one negative because VG is to the left? I need a double check. I need to work this slowly and make sure I understand. Braden?
Would the radius of gyration change when you take it about one head?
It's not asking, so because we did the extended equation for angular momentum about point A, look what comes up. It's not the mass moment of inertia about point A. It's actually still the mass moment of inertia about the center of mass. So for this problem, that's still IO, not IA. If we did need IA, yes, that would have to change. We'd have to probably do parallel axis theorem. Samuel?
Putting a negative in that equation doesn't give you the right answer.
Right here, this one is wrong.
Right, gives
Yeah.
you negative 12.7.
It does give you negative 12.7? Okay, because if it gives you negative 12.7, then what it's telling you is the direction of motion. Maybe it goes in the opposite direction. I need to double check. I also need to make sure that I'm not screwing up my signs with the roll without slip because now I'm worried that this really should have been a vector equation because of your question. So I will hammer this out. and get back to you on Thursday. I promise. Okay? Questions? Anything else? Do we understand the redemption assignment? If you came in late, please get your exam from me so that you have a hope of doing the redemption assignment.
Will there be an answer to this?
There already is an answer key posted for the exam too.
Okay, I didn't see it. I'll look again.
Look again. But the only thing is there's an error on the concept question 5. B is the correct answer, but my words are wrong.
That's fine. I'll work it out.
Yes, exam. Come on.
If it's a problem that you don't like, will you let us redo a different one?
Yes, but the likelihood that I looked that closely is probably slim.
Okay, great.
Is it Gonzalez? Yeah.
No, because
And so it's just do the problem and
Look at the assignment. It has the instructions.
No, I low-key don't know if I'm strong enough.
Who's next? Morning?
Wait, I'm not waiting for my exam. I was gonna ask her.
I just have a quick question about that.
Yep.
So for this one, I have the entire process right. I just accidentally miscompleted it. Do I really do still want me to do a whole separate problem just because I accidentally miscompleted it? Like, all my math is right. It's just I divided by 9.81 instead of 13. I'm just asking, like, do I have to do a whole separate problem just because of that? I mean, if you want me to, I will. But I was just, it's up to you. I was just curious.
It's not going to hurt you for the final to get another practice problem.
Right.
I
that's
just,
fine.
I would
No, I was
have
just curious.
whatever I tell you, I have to do for everybody else, which would cause me to have to regrade everybody. And
I'm just more mad at the fact that I just wrong.
I'm sorry.
Dang it.
Yep.
Two quick questions.
Yes.
First, this one, should I still do for the exam redemption? I literally just calculated the last thing wrong and I did it here. Should I still want me to do a whole practice problem for the... Okay. And
It's going to
then...
help you for the final.
Okay, yeah. And then, can you just... I was trying to look at the solution guide and I was still getting confused on this problem. This is the full...
Yeah. Agree.
Yeah. I was just...
Did you draw the three body diagrams of each of them?
Not when I was doing it because I forgot how to do it, but I saw that you had drawn them, and then there was
Draw them separately.
yeah. What was confusing me, I think, was having the friction force in there because then there's not like that completely cancels out when it doesn't.
You do equations of motion for one as separate from the other.
Okay.
So they don't cancel because the same friction force is not
It's
both
not,
directions
okay.
on one body.
Yeah. Okay.
Wait, people?
All right.
Does that make sense?
Yeah, I'll just have to redo it. And
Okay. If it's still not clicking when you're working it slower, let me know.
Okay. Also, for recitation tomorrow or no?
What? Yeah.
Okay. Thank you.
I have a question about the redemption assignment. I have an older version of the textbook, so like the numbers are moved around for some of the questions. So is it fine if I use that version, or should I?
Yeah, I don't think so. I don't care.
Okay,
It's
alright.
fine.
Just making sure. Alright, thank you.
Just make sure you double check the right answer in the back.
Alright.
Yep. What's up?
Good job. Okay, I have a question. I spent all this time looking there for the second question, like a question that was similar to that one. I literally couldn't find anything in the fundamental section
For particle kinetics with a polar.
with the polar. Maybe orange section only, by the way. Maybe
I mean,
like you can help me out.
It
here,
doesn't
because I
necessarily have to be with a pulley.
Oh really?
I mean, I just want you to
anything
find
from here?
anything from particle kinetics.
Oh, I
That's
thought you were, like,
kinematics.
looking for like a.
I mean, ideally, yes,
okay, I'm sorry.
but
I was
there's not all that many options in the fundamentals section. But I want you to use the fundamentals so that you have a solution guide and I don't have to write it.
Oh, wait. what
That's
chapter is
kinema-
this?
that's
Oh, this is
kinematics.
kinematics. Okay. I'm so sorry. I don't
You're
want
fine.
to bother you.
You're fine.
I can also just pop into your office hours at some point.
I mean,
too. Like, is that
just
fine?
do one with a rope.
Okay,
That's
wait.
fine. Question. Okay. Right? Yeah.
And the last one's what chapter? Do you remember?
I don't remember.
Okay, wait. It was a disc. What? Do you know? Does anyone remember?
Rigid
what
body
chapter?
kinetics.
Free body kinetics. Thank you.
Something like that. I don't know.
Right, hold on. Free body kinetics.
Bro, I wasn't paying attention at all. I only showed up because I was already here. I
That's what I was
last week.
like. I don't know. Really,
Got it. It's fixed. Thank you.
Is it this one? Plant your kinetics of a rigid body, force and acceleration?
Yes.
Thank you.
Yeah, just email me back and I'll send you a screenshot of that. Yep.
Wait, you could do that? Because I have 3 exams on that day.
Yep.
Okay.
Take it early. Just email me.
Okay.
Okay. Sorry.
Yeah, sorry.
What's your name? That's easy. What's your last name?
So what I did was 25. I did the hardest stuff. Everything else. Oh no, I did not. You just gotta watch the video.
You need to use that to find a relationship between the acceleration of the two bodies. Yes, that comes from the fact that these two things are connected to the same inextensible link.
You plugged in, so you use equation 3 to solve for tension, and then you plugged it into 2. Why did I not plug it into equation back into equation 2?
What do you mean?
Because I use equation 3 to solve for tension, and then I plug tension back into equation 2.
You'll get 0 equals 0. That doesn't work. You have to use the information that is baked into equation 2. Otherwise, you're just going to get that 0 equals 0.
Okay, last question. Can I just do this one for the last question?
Sure.
Okay, because it's from the same chapter, so it's just
Sure.
okay, thank you.
Although that's an impulse momentum equation.
Wait.
I think.
You sure it was?
Or
angular,
no,
it was angular velocity. It was solved angular velocity or something.
It was a change over a change in time. Check that it's in the right chapter. It might still be equations of motion, but it's going to cause you to integrate the acceleration.
Oh, I don't want to do that. Sounds good. I'm sorry.
Good lord.
Listen, I got my mind.